So hello, let us start the sample assignment of week 7. So the first question is, if y and z are independent random variables, then which of the following is true? So the first option is expected value of y given z is less than expected value of y. Option B is expected value of x given y is expected value of y and expected value of y. Expected value of y given z, expected value of y, and d is none. Yes, the right option is C. Because y and z both are independent, that's why we can write that f of y given z, the PDF, is equal to f of y. This implies expected value of y given z is equal to okay. Let's go to the second question. So the second question says that y and z are two random variables. Then I'm writing four conditions and you have to comment which of the following is true. The first option is expected value of summation of these two random variables is greater than expected value of y plus expected value of z. Is less than the individual expected summation of individual expected values. option C is equal to expected value of y plus expected value of z, and you have to comment which of the following is true.
So options A and C are same. It look greater than. Okay, okay, fine, fine. Okay.
So it's right. Expected value of x plus y. I write this. This is actually x p of x dx plus, if I take the expected value over these two variables, and y p of y dy. So basically, if I take expected value over these, its expectation is a linear operator, and if x and y are independent, then I can just separate both of them. Like, you can write it as x plus y p of xy of xy variables. This sort of, this is actually, if I say x plus y is a new random variable z, and y, I say that y has no dependency on the vector x in that term. So basically, expectation is a linear operator. So expectation of x plus y is sort of writing first doing the expectation over x plus then doing the expectation of over y, just like any linear operator. Like if you want to do the differentiation x plus y, so this is first doing dx plus dy dy. Similarly, expectation is also a linear operator. So basically, I can write the equation here that expectation of y plus z is actually doing expectation of y plus expectation over z. So the right option is option C. Because this is the linear equation. Okay. Let us move to the next question. Which of the following is a valid PDF. For lambda greater than 0. So the first thing we have to remember is, for fx to be a PDF, this condition must hold, that 0 to infinite f of x dx equal to 1. So if you look at the first option, that is 0 to infinite lambda square e to the power minus lambda x dx, this function will come as lambda if I do the integration. So lambda has no, I have not given any condition that lambda equal to 1. If lambda equal to 1, then this can be a PDF. But I have not said that lambda is equal to 1. So any value of lambda is not given here. So option A is not a PDF. Option C, let us check for option C. F of x dx is equal to 2. Just check it. Because this function is from minus infinite to plus infinite. Also this one. Forgot to write this thing. It is also from minus infinite to x to infinite. So what happens? I can write this function as this 2 and 2, because this is from 0 to infinite and it was from minus infinite to infinite and it was mod x value. That's why this is, I'm avoiding this mod x value, and as I'm avoiding this mod x value, it is getting 2 times, so that 2 times factor is here. Okay, and I am avoiding this mod x value here. So if I do this integration, it will come as 1 from 0 to infinite. Just you have to do the integration with respect to x. So option C is the right answer. And this is a function that stays from minus infinite to plus infinite. So basically this is not integrable within the range to minus infinite to infinite. So option C is the right answer. This is for x greater than 0. So lower limit is 0. For this one, the lower limit is 0. And also option C, the lower limit is 0. But for that it will be minus infinite to plus infinite. This function, lambda e to the power, if I get it, lambda e to the power minus lambda x minus infinite to infinite. And this is not integrable within this range. So basically it will not come 1 also. So option C is the right answer. I think it is clear for everybody. If anybody has any doubt, they can ask me at any point. Now let's go to question number 4. Question number 4 says we have a function that depends on the random variable y is e to the power 3y by 4 such that y is between the interval b to 0 and otherwise 0. So if I need this function to be a valid probability density, what should be the value of the constant b? So again, you can write that this should be 0 to b, this function only varies, and within this dy should be equal to 1. So this implies e to the power 3y by 4 dy should be 1 within the interval 0 to b. From here we can write b is equal to 1 by 3 ln of 3. This is the answer. And every time you have to check whether this function should be greater than equal to 0, because PDF can't be negative. obviously this function f of y is greater than 0. It's not a, it's always a positive, it's non-negative function. That's the key catch here. Even if this condition holds, but somehow f of y, so for some value it is less than 0, this will not be a PDF. This is the key catch here. Okay.
Uh, so I have a question. How did you get ln of 3?
So basically I have to do this integration. Okay. What is the integration for e to the power 3y dy 0 to b?
E to the power 3y by 3.
I think. Okay, let me check once.
Because I think it is ln of 13, I'm thinking.
Mm, oh, sorry, ln of 13.
Yeah, that's what I was getting ln of 13. And
It is also,
yeah, 13 it is.
yeah, okay, fine.
Because 12 plus 1,
1
the
plus,
minus 1 from the left hand side moves here. So it will be ln of 13.
yes, it will be ln of
Yeah,
13.
okay. Okay, thank you.
Question number 5 says there are three statistically independent variable random variables. Those are x1, x2, and x3. So what is the expected value of x1 is 4, x2 is 4, and also expected value of x3 is equal to -1. So I have to calculate a mean value of a function of f of x1, x2, x3, and the function is 4x1 x2 plus 5x1 x3 plus, wait a minute, okay, plus 5 x2 x3. So I have to calculate the expected value of the new random variable, that is x2 x3. So first of all, I have stated that these random variables are independent. So if the random variables are independent, I can write expected value of x1 into x2 is equal to expected value of x1 and expected value of x2. So the first thing x1 x2 expected value of, first write the whole equation, 4x1 5x1 x3 5x2 x3, 4x1 x2 plus 5x1 x3 5x2 x3. So first expectation is the linear operator. So I can individually take out all the elements. Expected value of 5x1 x3 plus expected value of 5x2 x3, and from here I again this property, if x1 and x2 are independent, then I can write in this following way. So it is expected value of x1, expected value of x2 plus 5 into expected value of x1 into expected value of x3 plus 5 into expected value of x2 into expected value of x3. This is equal to 4 into, just check what is the expected value of x1 and x2, both are 4, only x3 is minus 1. So at the first instant it is 4 into 4 into 4 plus 5 into, it is 4 but this is minus 1, plus similarly this is also 4 into minus 1. So this is 64 minus 20 minus 20. So this is 24. So the answer is 24. The answer is expected value of f of x1, x2, x3 is equal to 24. Okay. Now let us focus. Number 6th question. It says we have a joint probability distribution one by 12 is minus y by 4 minus z by 3, u of y, u of z. And from this we have to comment what is the probability of the event zero less than y less than infinite and z less than -2. What is the probability of this event? I think it is clear what is u means. U is the unit step function.
So can I know if z is less than or equal to -2 or z is less than -2?
Less than equal to.
Less than or equal to. Okay, thank you.
Okay. So the event is 0 less than y less than infinite. So in this interval, this value is 1. But if I think u of z value within the interval, that is z less than equal to -2, this value will be 0. So basically it says that y and z both can't be negative. Both of them, because there is a u function. So the probability will be zero, because this uz function that only strays from 0 to, and the value is 1 uz. I mean the domain of z to 0 to infinite, then only u of z is equal to, within this domain it is 1. But in the question it said that z is less than -2, so z is less than 0, and at that value u of z equal to 0. Let's go to the question number 7. It says that a random variable y is uniformly distributed. The interval -5 to 5. And another random variable is y is depends on this that x depends on y in this following fashion. So let's redefine the question. I made a mistake here. So it says we have a random variable that is x, and x is a uniform distribution that is within range -5 to 5. So now I can define the random variable y, new rv, a new rv, that is y, and this is 2x square. So question is, what is the expected value of y? So what is given here is that x has a distribution that is uniform between -5 to 5. So if I want to calculate expected value of y, that is equivalent to calculating expected value of 2x square, and then it is minus infinite to infinite 2x square f of x dx. But it is given that x has a uniform distribution between -5 to 5. So these limits will be -5 to 5 to x square dx, right? And why it is within this interval, it is, what will be the value? -5 to 5, it will be 1 by 10. Because a uniform distribution between -5 to 5, it should be this is from -5 to 5, so this value should be 1 by 10, because this distance is 10. So 10 into 1 by 10, this rectangle will keep 1, so that will suffice the f of x dx equal to 1, -5 to 5. This condition will hold if this magnitude is 1 by 10, because stretch is from -5 to 5. So that's why 1 by 10 factor is here, this 1 by 10, because its magnitude is 1 by 10. So if I calculate this, it will come 16.67. Now let us go to question number 8. It says y1 and y2 is a two independent random variable, and they are also, in this case also, they are uniformly distributed. So y1 is a uniform distribution and y2 is also a uniform distribution. This is for y1, y2. Probability is from independent, and another point is here, they are also identical. So y1 is the distribution that actually stretches from minus a to a. Similarly, y2 is also stretched from minus a to a. These are two different random variables, I can say, but however, both of them are uniformly distributed. They are independent of each other. So y1 and y2 are independent. Expected value of y1, y2, expected of y1, and expected value of y2, that I can write, and they are identical, and they are stretches from minus a to a. So basically that is 1 by 2a. This value. To hold the equation f of x dx minus infinite to infinite equal to 1. Now we have to comment what will be the density. Like this density is a square pulse with 1 by 2a amplitude. So what will be the density of y1 plus y2? What is the probability density function? Okay. So one sort of notation is both of them are a rectangular pulse. As we have discussed earlier for the Fourier transformation, this is a rectangular pulse with a width 1 by 2a. I mean amplitude of 1 by 2a and width is 2a. So this is the amplitude and this is the width 2a. This is the width, this is the amplitude. So let's write the answer in this way. So another representation of this uniform distribution is, and also for f of y2, y is the amplitude 1 by 2a, the rectangular pulse, y by 2a. So now the probability density function z is y1 plus y2. So if this is the rule, we know the distribution probability density function is the convolution of y1 f of y2. So basically if I do the summation here, it is actually the convolution between these two PDFs. So what will come? So convolution of these two square pulse convolution it will give us a triangular pulse. And each of the square wave has a width of 2a. So triangular pulse will have a width of 4a. So the density nature will be a triangular pulse with width of 4a. Question number 9. So this says the envelope of the output signal of a radar system is a random voltage y. This is random because there is presence of noise. So the distribution of the y, that is random variable y, this RV, is given as y e to the power minus y square by 2. So as this y is a received signal, it may have two cases. First, it gives a true value or a false value when it triggers. Like this radar is receiving, probably we need 100 voltage. Okay, so or 5 voltage. Let us think like that. So there are two conditions. Because the signal came and the radar gives us the notification that some signal it has received. So that is the true case. Another case can be like, because there is noise, there could be false alarm. Like there is actually no target, but what happens, the noise triggers the receiver output threshold, and it says there is a target, but that is a false alarm. So the probability of that, the system gets a false target detection if the random variable y that also contains a noisy term exceed the threshold voltage level VTH. Exceed VTH. So now we have to make the probability of false detection 0.0001. Then what should be the value of V? So let me repeat the question once again. So we have a output signal of a radar system, and that generates a random voltage, that is the noise, is Y. This Y is the noise. And the PDF of the noise is given in this way. Now, suppose the system receives a signal S plus this W, S plus this Y. So when the signal is not present, the Y is always present in the system. So if the signal is present, probably it will exceed the threshold V. But if the signal is not present in some case, at that case Y will also provide some voltage, and we have to make sure such that this Y does not exceed the threshold voltage V. So that is the probability we have to reach, that Y exceeds V, that should be 0.0001. For such region, what will be the actual threshold voltage VTH? That we have to calculate. I think the question is clear. So what should be the probability of false detection? So the signal component is S and the noise component is Y. So when the signal is 0, the output is only Y. So this Y should not exceed this V threshold. But why we have no control over Y? Because Y is a noise signal. So we have to set VTH such that Y does not exceed this. But the distribution of Y is said y e minus y square by 2. So the domain of y, it can go to 0 to infinite. I mean, converse when limit y tends to infinite, its value will be 0. So the curve will be some sort of like this. So basically, if I say this is the point VTH, the probability that this exceeds the integration over this region, the probability over this region should be 0.0001. That is the case we have to calculate. In this region, if it may happen that, like, suppose a normal scenario, I can give an example that will be better. So probably the signal detects at 5 voltage, the threshold is 5 volt. So noise should have a higher probability before it exceeds 5 volt. So noise can be 0.1 volt, 0.2 volt, maximum 1 volt, but the probability of 5.1 volt should be less than 0.00101. That is the thing we have to think. Like, if noise exceeds 5.1 volt, then even if s equal to 0, the summation of s plus y, that is the received signal, that is 0 plus 5.1, that is 5.1 volt. But if the noise is 0.1 volt, then 0 plus 0.1 volt is equal to 0.1 volt. So this does not exceed this 5 volt threshold. So in this case, the false detection will not happen. But if the signal is 0, but still the noise is 5.1 volt itself, at that case the output will be 5.1 volt, and at that scenario the false detection will happen. So for such reason, it should be, we have to see that from V to infinite, this is V, and it goes like this, and this is VTH. So from VTH to infinite, f of y given y dy should be 0.0001, or this VTH to infinite, y to the power minus y square by 2 dy should be 0.0001, or e to the power minus v square by 2 should be 0.0001, or v should be root over 2 ln . So the threshold will be this. This is also VTH. Okay, the last question of today's session. This is a joint sample space for two different random variables that are y and z has four elements. So let me write it, y and z. The first is both can be 1, second is both can be 2, 3 and 4, 4. And the corresponding probabilities I am writing here is, this is the probability values, this is 0.1, this is 0.35, this is 0.05, and this is 0.5. So we have to calculate the probability of the event y less than 2 and z less than 6. So it says y less than 2 and z less than equal to 6. So y less than 2, and if this happens, from this joint sample space we can say that z is also less than 2. Only the possible region is for this thing is z equal to 1, because for y equal to 1, z equal to 1. So only possible sample space of this is this sample space, because there is no equal to sign. So the probability will be 0.1. Okay, question 6 I have to repeat once, right? So okay. Question 6 8, we have given a probability density function z is equal to 1 by 12 e to the power minus y by 4 z by 3, and unit step function u of y and u of z. So we had to find out a probability of the event. This is 0 to y less than infinite and z less than equal to -2. So you can see from here that u of y, the function, is 1 for y 0 to infinite. This is infinite. And u of z is also similarly 0 infinite. Sorry, notational, I mean that y should be greater than 0 for these values. Similarly, this should be z should be greater than zeros. Because these are the unit step function. So the domain says z is less than -2. So what will be the value at u of z at z less than equal to -2? This will be 0. So following this probability density function will be 0 for the region z less than -2, because u of z function, that is the unit step function, is only valid for z greater than equal to 0. Following this will be 0, and if the probability density function is 0 for a region, I mean from -infinite to 0, this region, this probability density function is 0 for both the values y and z. Like if y is in this region or z is in this region, this whole function value will be 0. If y is less than 0 or z is less than 0. So as z is less than -2, less than equal to -2, so this value will be 0 at this position. So this is 0. The answer will be 0. Okay, so this was all for today's session. We will meet in the next Sunday.